Hello all, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In July lecture series, we are going to discuss about modeling in virtual reality in medicine. And in today's series, we are going to discuss about virtual reality geometric modeling. Okay, first, see here the virtual reality system architecture. It includes modeling and VR toolkits. And VR engine, it consists of multiprocessor graphics accelerator. And in IO devices, we have mouse, joystick, glow, HMD, head-mounted displays, etc. Also, we have user, which consists of programmer training, etc. And we have task, training, programming, teleoperation, etc. So, the whole VR system architecture, it consists of VR engine, IO devices, user tasks. To manage all these, we need modeling and VR toolkits. Okay, here VR modeling and VR prototyping are related but distinct concepts in the field of virtual reality. VR 3D modeling means creating 3D model of an object or design using VR technology, using controllers in 6 degrees of freedom DOF instead of a flat screen with mouse and keyboard. Geometric solid modeling allows engineers, architects and designers to create realistic virtual representations of physical objects as geometric solid models. This technique transforms ideas into representing solid models in 3D with a final solid shape in virtual space. Here in virtual world, it consists of geometric models which is represented in a 3D Euclidean space with Cartesian coordinates. Here in this geometric models are of surfaces or solid regions in R3 and contain infinite number of points here. See here the VR geometric modeling. Here the object surface shape and polygonal meshes and splines, object appearance, lighting and texture mapping are covered here for geometric modeling. Here in surface polygonal triangle mesh, we consider a shared vertex, also non-shared vertex. Here the triangle meshes are preferred since they are memory and computationally efficient with the help of shared vertices. See here the vertices x0, y0, z0, x1, y1, z1, x2, y2, z2, x3, y3, z3 and x4, y4, z4 and finally we have x5, y5 and z5. See, in this object splines based shape, it is another way of representing virtual objects. Here the functions are of higher degree than linear functions describing a polygon. Use less storage and provides increased surface smoothness. Here, these parametric splines are represented by points x of t, y of t, z of t. And here t equal to 0.1 and here a, b, c are constant coefficients. See here x of t, y of t and z of t. X of t is equal to ax multiplied with t cube plus bx multiplied with t square plus cxt plus dx. Same for y of t, ay t cube plus by t square plus cyt plus dy. For z of t, az t cube plus bz t square plus czt plus dz. See, in this object spline based shape, parametric surfaces are extensions of parametric splines with point coordinates given by x of st, y st, z st with s equal to 0, 1 and t equal to 0 to 1. Here we consider beta splines are controlled indirectly through 4 control points and we have physical and also we have more detail in physical modeling section we have. And here we consider the T and S. See here in this object polygonal shape, it can be programmed from scratch using OpenGL or other toolkit editor. It is tedious and requires skill. It can be obtained from CAD files. It can be created using a 3D digitizer or a 3D scanner, tracker, cameras and laser. It can be purchased from existing online databases and files have vertex location and connectivity information but are static. See the geometric modeling. See here. See the geometric modeling here. The CAD file based models are shown here. It is done using AutoCAD and each moving part has a separate file, and these files need to be converted to formats it is compatible with VR toolkits. The advantages is use of pre-existing models in manufacturing applications we have. See here the CAD file based models. With the help of Autodesk, we can create it. Geometric modeling. It is very tedious fun, but we have to create it perfectly for a better virtual reality environment. Also, we can use the pre-existing models for manufacturing the upcoming applications. See here the 3D scanners. See here. In this, it eliminates direct contact with object. See here, it uses two cameras, a laser and magnetic trackers if movable objects are scanned. Scanning resolution is 0.5 mm at a 200 mm range, and scanning speed is 50 lines per second, and range is 75 to 680 mm scanner object range. This Polymus 3D scanners, which gives a better experience in VR world. See the examples for geometric modeling. It can scan objects up to 3 meters long. See the conversion of scanner data. Here the scanners produce a dense cloud of vertices X, Y, Z. Using such packages as a wrap, the point data is transformed into surface data, including editing and decimation. Here we have point cloud from scanner and polygonal mesh after decimation. See the difference. See the perfect match. Here we have example polygon surface, and we have non-uniform rational beta splines patches, and we have NURBS surface at last. Okay, with the help of this geometric modeling, we can have a better object visual appearance. Okay, for this we need scene illumination, local or global, texture mapping, multi-textures, and use of textures to do illumination in the rasterizing stage of the pipeline. See the scene illumination part, local methods, flat shaded and Gauraud shaded and foam shaded treat objects in isolation. They are computationally faster than global illumination methods. Here this global illumination treats the influence of one object on another object's appearance. It is more demanding from a computation point of view, but produces more realistic scenes. And next one is texture mapping. It is done in the rasterizer phase of the graphics pipeline by mapping, assigning texture space coordinates to polygonal vertices or splines, then mapping those to pixel coordinates. Texture increases scene realism, and the texture provide a better 3D spatial cues. They are perspective transformed, and also they reduce the number of polygons in the scene. It increased the frame rate. Example, tree models. And this geometric modeling, the best use of geometric modeling is it allow more complex textures. See the normal one and reflectivity of texture, bump maps and background texture and transparency texture. Thank you.